Bonjour tout le monde. Alors, je ne sais pas encore si on a des gens qui sont arrivés. Hop, alors je vois qu'on a 2 visionnages en cours, y compris un qui doit être certainement moi. Donc bienvenue, 3, ça y est, ça commence à monter. Les gens commencent à arriver. N'hésitez pas à voilà, passer dire bonjour dans le chat sur YouTube, à me dire si tout marche bien, si vous m'entendez bien, s'il y a des problèmes de son, d'image, ou d'autres problèmes d'ailleurs. Et puis voilà, je vous laisse vous installer tranquillement et puis on va essayer de commencer tranquillement aussi. I just realized I'm speaking French, whereas I'm supposed to speak English. So welcome everyone. Take a seat. We're going to start in a few minutes. Feel free to say hi in the chat. We're going to start, yeah. Tell me if everything is working fine, if there are sound issues, video issues, any kind of issue, feel free to tell me in the YouTube chat. So today I will be alone. This time Roxy couldn't make it and join me for the live, sadly. But yeah, we're going to make it work. I'm just waiting a few more moments in order to be sure that everybody that wanted to attend at the time to make it to the live session. I'm checking as well that everything is working fine. It seems to be working. All right. So let's start. And if anybody misses, hi. Hello, Alphonse. Okay. Thanks a lot for the feedback on video and sound. I think we're going to start. Maybe some people will join during the session, and if not, they can always rewatch the stream later on the replay. It's perfect. So just a quick reminder of what the Plan B Labs Lightning is and what is the goal of this kind of live sessions like the one we are doing today. So the goal is to keep track of recent developments in the Lightning space at large. It's to dig deeper into specific aspects of the Lightning Network protocol as well. So this is more technical aspects, whereas on the first bullet points, keeping track of recent developments in Lightning space can also be more seeing new company launches, new product, new features, and stuff like that. And the end goal is also to be able to contribute to the ecosystem through projects like research papers, tools development and stuff like that. So the end goal is to have a small community in the Plan B Labs that could someday contribute to the ecosystem and build stuff, conduct research, and stuff like that. Who am I quickly? So my name is Fanis. I'm a contributor to Plan B Network educational content with the LNP 201 course, which is basically a course that gives the essential things to know about Lightning from a technical standpoint. And I'm a developer at LN Markets and DLC Market, which are two companies which work with finance, derivatives trading, and Lightning and Bitcoin, and DLC, which are some kind of Bitcoin-related smart contracts. And so what happens during live sessions? So live sessions of the lab are not courses. It's quite important to note that. The idea is that it's as interactive as possible, both before the session, because everybody is free to propose a subject beforehand, and everybody is encouraged to participate. So feel free to participate in the chat, ask questions, make remarks, and you can even join me on stage. The easiest way for that is to reach out on Telegram. I'm going to explain that in a minute. Just one quick note. It's important to note that lab sessions are recorded and replays will be available. So it's great because it means that if you miss a live session or part of a live session, you can always watch the replay. But it also means that if you wish to participate, either in the chat or by coming on stage with me, remember that everything will be recorded and a replay will be available. So that's something to keep in mind. For example, if you don't want to show your face or your name. But you can always come on stage with only your voice if you don't want to show your face, for example. Great. And so I'm going to skip this one quickly. I mentioned that we now have a Telegram group, which is where you can join us basically to chat together between live sessions. So we will have a live session every 2 weeks on Tuesday at 4 p.m. CET. So I think it's 3 p.m. UTC, but basically it's the same time as now. And in between live sessions, you can come on the Telegram group to chat with member of the team, with other students, with basically everybody that is on the Telegram group. And we have a few dedicated channels in this group, for example, in order to share recent Lightning related news, to share new Lightning development, to share research papers and stuff like that. And there is also a live chat channel in the Telegram where you can post messages during live sessions, and where you can also ask to be added to the stream if you want to come on stage and ask questions or make remarks. The easiest way for you to do so is to just drop a message in the live chat channel on the Telegram group, and then I'll DM you with a link in order for you to join me on stage. And so it's effective today. So if at some point you want to share something, you want to discuss something, feel free to drop a message on the live chat channel in the Telegram group, and it will be my pleasure to have you join me on stage today. A quick reminder, yes, about some kind of requirements. So I put quotes because it's not really hard requirements. It's just that if you have basic knowledge of how Lightning works, things should be easier to follow. but it's not mandatory. You can come with no knowledge at all and just learn as you go. But basically, what is kind of expected is basically what is covered in the LNP21 course that I made for Plan B, which is basically how Bitcoin transactions work. So the concept of UTXOs, for example, how Lightning channels work as well, and how payments work on Lightning. So with things like invoice, HTLCs, onion routing, and stuff like that. But it's not, once again, it's not a strict requirement. It's just that it will be easier for you to understand, especially the more technical parts of the sessions. But there are not everything during live sessions is technical, not at all. So you can just, yeah, come with us and listen to what we say and ask questions if there are some things that are unclear. A few rules that apply to both the live sessions and the chat. They are quite simple rules, I think. Be respectful of everyone, both during lives and in the Telegram chat. Know that the chat will be moderated, so please be nice, keep discussions on Lightning topics and Lightning adjacent topics. Like, for example, if you want to talk about something happening in Bitcoin that is somehow related to Lightning, or if you want to talk about other layer twos on top of Bitcoin, it might be okay depending on what exactly we are talking about. If you'd like to propose a subject, it's best to propose in advance. For example, it's the Telegram group. And usually I will be preparing stuff like the slides that you're seeing right now, or I'll be collecting links and stuff like that. But you can also prepare something if you want to present something to the group, or ask me to help you to prepare some stuff. So yeah, it's basically, the idea is that it's not once again, it's not a lecture. It's more like a working group in order to try to build a small community of Lightning enthusiasts who want to understand more of how Lightning work and stay on track with recent developments. And so today, what are we going to do? Today we've got 2 weeks worth of news to unpack. So I've selected a few things that happened during the last 2 weeks and that I found interesting and that we can discuss today. So here is a short summary of what we will try to cover today. So there was a Lightning Network report by Fidelity and Voltage, which was quite interesting, notably thanks to data that Voltage provided. There is a public service announcement regarding LeafPay, which is a quite popular custodial wallet, which is suspending operations. So I thought it was useful to just make a quick PSA regarding the fact that they are suspending operations. There is some discussions and related to a blog post by Matt Corallo on custodial solutions. There was an interesting case study by BTCPay on how Unbank, which is an ATM network provider, how Unbank integrated BTCP solutions and how it benefited them. A short overview of Albi Hub's first 6 months. So I'll recap what Albi Hub is exactly, but I think it's interesting to see how things went during the first 6 months of Albi Hub. We'll go back to last week's big FUD, which was over LND and whether there was a vulnerability in LND or not. And then we'll cover some specification stuff. Because as you know, Lightning Network is both a specification and a few implementations. And the specification is basically telling all the implementations how they should develop their solutions so that all implementations can stay interoperable which is very important, of course. And so there were two new items added to the specification in the last 2 weeks. One which was merged, so it's actually in effect in the specification, which was around redesigning mutual clause with an optional simpler protocol. And then there is an ongoing draft regarding zero fee commitments for mobile wallets, but not only. So there was a discussion about mobile wallets, but there is also a specification draft currently in order to support zero fee commitment. So we'll see what zero fee transactions are and how it plays with Lightning, but it's at the draft stage right now, so it's not finished at all. So hopefully we'll be able to discuss more about this zero fee commitments in the future as the specification evolves, and it's as it gets polished over time. So first, yes, we are going to see this new report by Fidelity Digital Assets in collaboration with Voltage. I actually found it quite interesting because quite often with this kind of reports, what is actually missing sometimes is actual data in order to support observations. And here in this one, thanks to the inputs from Voltage, there is actually some data, which I think is quite high quality data. And so for those who don't know who Voltage is basically AWS, but for Lightning. So basically, they can host a Lightning node for you if you want. So it remains a self-custodial node in the sense that basically you should the key is only yours. So it's as much of a self-custodial node as if you were running a Lightning node on AWS. So there is still the risk that the cloud gets hacked, for example. So that's the big difference with having your Lightning node in the cloud versus having it hosted on-premise, so either at home or in your company offices. But that's it. That's the only difference, pretty much. So it's self-custodial Lightning node hosting, and so given that they have access actually to quite some data for a subset of the network, of the Lightning network, which is basically the subset of nodes that are hosted by Voltage. So basically, the part of the data here used in the report is data from Voltage customers, because one of the features, but which can also be a complication when trying to build Lightning reports, is that a lot of information on Lightning is private. And so it's not like Bitcoin where we can see a lot of things on chain, for example. So it's not like in Bitcoin where a lot of things are publicly available. In Lightning, a lot of things are kept private by design. And so unless you have a company like Voltage, which provides anonymized data, you can't really do high quality with lots of data, high quality reports with lots of data. And here it's not really, there is some data from the Voltage, which is quite interesting. I made a few bullet points here, and I think we'll go directly into the report itself in order to zoom in these different points. Yeah. So one observation is that the 90th percentile of capacity per channel fell significantly below the average, which means that the average capacity per channel now is higher, and by a lot, than the 90th percentile of capacity per channel, which means that there are a very small number of nodes which have a lot of capacity, to the point that they bring the average capacity per channel above 90% of the capacity of all channels. So there are quite a few number of nodes which have so much capacity in the channels that they tend to bring the average capacity per channel far higher than not even the median, but the 90th percentile, so 90% of the network. Another observation is that the average fee rate, so you have to the average fee that you have to pay when you make a Lightning payment, as expressed as a percentage of the payment volume. So this average fee rate decreases with payment size. And so it's especially high for micropayments and quite small for big payments. On the opposite, average payment speed increases with payment size. And so the speed is especially low, not high, for big payments. There is a mistake here. So it takes a lot of time for big payments to settle on Lightning, and we'll see what is big in this context. And finally, a final observation, which I think is quite today is considered as something that is well known, but it's always good to have some data to back this observation, is that the biggest impact on transaction success rate is the number of hops in the route. So I'll just quickly open the report. Here you go. So you should see my screen. And so I've prepared some a few notes. So yeah, here there is this observation, which is, as I said, that the 90th percentile of capacity per channel fell significantly below the average, which is what we can see in this graph here. So as you can see, so 90th percentile is basically 90% of nodes. And so for some time it was quite above the average, which makes sense. But now, and since let's say mid 2022, the average is actually far higher than the 90th percentile, which shows that there are a few nodes. So probably we're talking about Lightning service providers, which have very big channels with a lot of capacity, and which bring this average very high, whereas most of the network is comprised of smaller companies or individuals who have Lightning channels that are sized according to their needs, so for peer-to-peer transactions and stuff like that. So it shows two things, I believe. One thing is that, of course, there is some kind of liquidity centralization on Lightning, which we all know is occurring, and it's something that is quite natural in such a liquidity-based network. And so it's basically LSPs like Async, Breeze, Zeus, and stuff like that, who need to have big channels. There is LN Big as well, and other big players. But it also means that there are a lot of smaller channels which belong to individuals, which is also great in terms of decentralization. And so that's what basically this sentence says. Inside this decentralized network, peer-to-peer transactions are still unlikely to require a substantial amount of liquidity. LSP nodes need to operate at a significantly higher capacities than an individual's node because they require the liquidity to handle a plethora of user transactions. In contrast, an individually owned node would theoretically be more focused on the personal transaction amount. The difference explains why the average capacity per node is significantly higher than 90% of the network. It's quite interesting, I think. Then there is the average payment fee, which we can see in this graph here. And so that's what I said in my bullet points, as I mentioned that the average fee is very low for big payments. We can see here that for example, for between 100,000 to 1 million Satoshis, so in USD terms, it's approximately 100 to 1,000 euros. So for this kind of amount, the average payment fee, so once again, it's on voltage sample set, so it's only voltage nodes. But for this node, the average fee is 0.02%, which is very low, especially compared to more traditional payment rails, for example. But on the other hand, when you go to smaller payment sizes and, for example, micropayments, so payments between 0 to 100 sats, here the fee is actually pretty big, something like 13%, which comes from the fact that on Lightning there are two parts in the fee that you pay. There is the fee rate, which is proportional to the amount that you are transferring, and there is what we call the base fee, which is an amount that you pay once for every payment. So, for example, if there is a 1 Satoshi base fee, it means that you will need to pay 1 Satoshi at least, no matter what the size of the payment is. And so if you're trying to make 10 Satoshis payment and you're going through a 1 sat channel where there is a 1 sat base fee, no matter what the fee rate is, you'll pay at least 10% fee. So it shows that Lightning is working great in terms of being a cheap payment system for payments of the everyday life, like something that when you're buying groceries, for example, you'll be probably somewhere between the 10K to 1 million sats area. So there you pay basically around 0.05% or even less, which is great. And you should expect to pay a higher fee rate, so a higher percentage fee when doing micropayments. But on the other hand, Lightning enables you to do such micropayments, whereas, for example, on a traditional system, you can't even do this kind of payments. So, and yeah, 0 to 100 Satoshis is really micro payments. And we can see that for 100 to 1K, so it's basically between 10 US cents and $1, you end up at 1%. So basically there is a really a steep decrease in the average payment fee once you go out of this 1 to 100 sats area. And I guess this, if you add smaller, if you divided the 0 to 100 in between, for example, 0 to 50, I guess we'd see that the 13% comes a lot from the 0 to 50 area and not from the 50 to 100. So I guess it's really very small payments that drive this amount, this number up. And so I mentioned as well that the average payment speed statistics, which we can see here. So here, for example, once again, it's on voltage sample set, but we can see that unless you're making quite a big payment, so 1 million sats and more, your Lightning payment will settle in 1 second or less, which is pretty fast. It's faster than a lot of traditional payment system, and it's faster than any blockchain-based system. So I think it's quite impressive. So it's on voltage sample set. So it's not. It's probably if we were to extrapolate this to the whole network, numbers would be a bit higher. So it would take more time for payment to settle. But it shows that it's possible with good nodes, good connections, and stuff like that to achieve very quick, very very performant payment speed. And probably we have the same effect here. It's probable that if we were to split the 1 million plus category into smaller categories, we would see that there is probably quite a large tail at the end, which explains for a lot of the increased payment time, payment duration. But it makes sense because when you're trying to do payments of the order of magnitude of 1 million sats or more, basically you're trying to do payments that are the same order of magnitude than that of the Lightning channels themselves. So you're going to have to split your payments into smaller parts and to go through multiple channels. And if you're trying to do a 10 million sats payment, it's probable that you're going to need to use a great part of the liquidity of multiple channels, which explains why it's going to take some time for the payment to settle. And I think that 7 seconds is okay, especially when compared to on-chain settlement time. And then there is the success rate. And it's interesting because, so as we expect, the average payment success decreases quite quickly with the number of hops. So a hop is a routing node in the route. So it's zero if you're directly connected to your peer, the person you're trying to pay, and it will be one if there is one intermediary node on the route, and two if there are two nodes on the route, and so on. And so if there is only one hop, it's 99% success rate. If there are two hops, it's 91%, so it decreases quite quickly, as we expect, and so on and so on. But what is so interesting is that if we categorize payments by amount, we see that we don't get the same result for the top category. But the payment success rate is more evenly distributed across categories. We don't have a drop from 99% to 90% by just adding one hop. We can see that between 0 to 100 and 100 to 1K, it's quite the same. And it only drops when we begin to go into the 1K to 10K and more sections. And then it's quite evenly distributed as well. So, and once again, it's on the voltage sample set, and so it's not completely indicative of the whole network, and numbers would probably be a bit smaller on the whole network. So yes, that's basically it for the report. I found it quite interesting because for once we have data to back our observations. If you want to take a look at the report, I provided. Let me share my screen again. Share screen. All right. Yeah, here I provided a QR code which you can scan, and it will take you to Voltage page where you can download the report. Hi, Chris. Welcome. So I don't know if there are questions at this stage. Feel free once again to come join me, to post your questions in the chat, etc., etc. And if there are no questions, I'll just go with the next, the next slide, where I wanted to share another data source, which was Ambos. So Ambos is basically a data company in the Lightning space. So you can check out their website. So I think their blog is ambos.space and their website is ambos.tech, or maybe it's the other way around. Yeah, no, their website is ambos.space and their blog is at ambos.tech. All right. And so here what we are looking at is a simulation. So it's not real observed data. It's a simulation using crowdsourced and randomized data. So it's backed by real data, but it's simulations, showing the probability of success for sending funds from and to anywhere in the considered subnetwork. So it's you take the whole Lightning network, and so the whole Lightning network would be the entire network line, which is the gray one, which is the one that does the worst. And you're trying to send a payment. You evaluate the probability of success of sending a payment of a given amount from any node in the network to any other node in the network. So you're basically taking the worst case scenario. And so what we can see is that for example, I don't know, the equivalent of $10, even in the entire network, we are around 95% success probability. But then once we reach $100, we are like at 75%. So on the entire network, it drops pretty quickly. But then if you say, let's remove the 10% worst, so least performant nodes of the networks, then things improve quite quickly. So for example, even at $200, we still have more than 80% probability. And once again, it's from any node on the subset, on the subnetwork we are considering, to any node on this subnetwork. So it's not between two specific nodes. So yeah, I think it's quite interesting to see that there are a few nodes that contribute to diminishing probability of success. Of course, when you look at the top 10%, of course, things are working much better, but it's only the top 10%. But yeah, overall, I think it's not too bad. And it's it also means that the network is actually usable for everyone according to their needs. So for example, big financial institutions, for example, exchanges, big companies, they will need to transact thousands of dollars worth of Bitcoin in the Lightning rails. And they can do that by having a good Lightning infrastructure. So they will probably be in the top 10%. Whereas individuals, hobbyists, and people like that will probably need to transact only smaller amounts, and they can have a reasonable payment reliability for the amount that they want to transact with medium grade infrastructure. So basically a Lightning node that you're running at home is doing perfectly fine. So that's it for the data and reports part of today's session. Um, I wanted to make a quick PSA regarding LeafPay suspending operations. So they I believe they sent emails to their customers and they posted on various social medias, social networks, sorry, as well as on their websites, that due to regulatory requirements, they were suspending operations. So they say temporarily. So I don't know if they will be able to come back, but for now it's temporary. Uh, and so it was for those who don't know, LeafPay was a custodial wallet which offered Lightning address, Bolt card support, and which had Nostr integration, so you could use it to send and receive zaps, for example. And so yeah, if you're using LeafPay, you have until April the 24th to withdraw funds from LeafPay. After that, you may still be able to withdraw, but they cannot guarantee it. So yeah, if you're using LeafPay, please withdraw as soon as possible. And speaking of custodial solution, Matt Corallo, which is quite a prominent Bitcoin and Lightning developer, published a blog post on Spiral blog. So Spiral is being yeah, Matt's employer, I guess we can say. So I'll just share the article itself directly. Chat again, but basically it's it's a bit of a rant on where things are at currently. The fact that maybe there has been too much of a focus on building custodial solutions in order to have nice UI, nice UX for users. And so yeah, it's covering a bit of the history behind the development of Bitcoin and Lightning. How at first, things kind of sucked, and how it's getting better, but we're still a bit far from something that is really usable by someone that is normal and that doesn't want to take too much time managing the Lightning system. Um, and yeah, so basically, if we care, I'm going to quote the article here. If we care about the principle of Bitcoin, we must bridge that gap. That gap being the gap between custodial and self-custodial Lightning. Mutiny started, so Mutiny was a Lightning wallet, started down the path before they pivot away from Bitcoin wallet software that seemed compelling. Wallet software should seamlessly transition between the best option at each balance. For the class of Bitcoiners with a balance too small to reasonably provide a self-custodial option, stores their funds in one of the custodial solutions Bitcoiners have spent so much energy building lately. For those with considerably more wealth in Bitcoin, where a non-custodial option makes sense, migrate their balance to something non-custodial. Given the options today, Lightning directly on a Bitcoiner's device is the only viable option here and ultimately must play an important role in any wallet wishing to consider itself a standard bearer for Bitcoin. So yeah, basically it's I think it's a nice reminder of what the goal should be. And so for those who don't know, Mutiny was so now they moved things to other things, but what they had built was Lightning wallets that could run in the browser, which made it easy to run as a what we call a progressive web app. So basically a web app on your phone. And so what they did was that for small amounts, where the amount is so small that it doesn't make sense to open a channel, users would have their balance in custodial eCash. And then once their balance had accrued to an amount where it made sense to create a real Lightning channel, the wallet would automatically create a channel for them, which I think makes a lot of sense. And we're not seeing so much of this kind of system today. Now we tend to have either fully custodial systems like Wallet of Satoshi or LeafPay, or we can have uh, custodial systems that rely on federations. For example, wallets like Aqua, for example, where you have your funds stored on Liquid, which is still custodial because you're trusting the federation. And even if there are lots of members in the Liquid Federation, you are still trusting a set of custodians. And on the other hand, there are completely self-custodial wallets, and I don't think there are much in betweens right now. And so maybe Mutiny left a void that is still waiting to be filled again. So that's it for Matt's rant. We also saw an interesting case study from BTCPay Server. So from time to time, the BTCPay team publishes case studies of other companies or projects that are using BTCPay Server, for their operations. And recently, they published this one about Unbank. So Unbank is like it says here, it's the oldest and most established Bitcoin ATM network in the US. So basically, you can go to the ATM, buy or sell Bitcoin. Now they also have an application which lets you kind of redeem vouchers and find ATMs where you can exchange cash for Bitcoin. And they had a provider, but it didn't work well, and it was quite costly. And so they decided to switch to BTCPay Server. So they run their own BTCP server instance, completely self-hosted on a virtual private server. And so they have to handle the maintenance of the system themselves, but it seems to be quite manageable. Of course, the cost is it's much less since it's open source software. So they only have to pay, as they say here, anything between $30 to $40 amounts for the server, and they have to maintain their servers themselves. And so the result is that between the moment that they switched to BTCPay Server and December the 31st, 2024, they processed 416 transactions with a gross volume of $40 million. So I picked this case study because it shows that BTCPay Server can be used actually for quite big projects. Because sometimes we can be under the impression that because it's open source, maybe it's not really made for big companies which need to do a lot of transactions, a lot of volume, a lot of transactions per second and stuff like that. But it seems that BTCPay is actually enough and actually better than closed source solutions. So it's something that we expected, but it's always good to have some case study to support it. Another great thing I saw, I think it was published last week, February the 19th, so 6 days ago, is some review of the first 6 months of Albi Hub. So as a reminder, Albi, at first it was a browser extension for desktop for your browser in order to be able to use Lightning in the browser. And they had some kind of a custodial offering where you could have a custodial wallet in your extension. You could also connect the extension to a self-custodial node that you were running, for example, at home. But they also offer a custodial solution for users who didn't want to self-host a Lightning node. But they decided so a few months ago to sunset this custodial offering, presumably because of of regulatory concerns, I guess. And they pivoted by offering Albi Hub, which is basically a Lightning node with more things inside in order to make it easier to connect to external wallets. But it's basically a Lightning node, which you can either run on Albi's cloud, a bit like Voltage, or you can run on any device at home, for example. And they shared data. So this data is only for Albi hubs that are connected to an Albi account, because you're not forced to connect your Albi hub to an Albi account. You can decide to just run Albi hub in order to, for example, facilitate Nostr Wallet Connect connections between your node and any Nostr Wallet Connect enabled application, so be it Nostr app or wallet. And so there are been 53 Bitcoin deployed in liquidity, 4,000 channels opened, and 5 LSPs helping with all this channel opening. And I think it's actually quite a success, because I mean, it must be quite hard to have a user base that is to some extent relying on your custodial solution, and then being able to migrate them to a self-custodial solution where they either have to pay a monthly fee, when they are running Albi Hub in the cloud, or they have to self-host Albi Hub completely. And so seeing that 53 BTC were deployed using Albi Hub, and only with users that decided to connect their Albi Hub to their Albi account, is quite an impressive number. And so it echoes with Matt Corallo's blog post we saw earlier, in the fact that it seems it's possible and it's doable to if you explain things properly, and if you accompany, if you help users correctly, it seems to be actually possible to help them migrate from custodial solution to self-custodial solution. So I guess it's been a quite intense 6 months for the Albi team, but I think the results are here, and it's quite inspiring, I believe. Yeah, so that's it for this quick segment on some various interesting news that we had from the ecosystem in the last 2 weeks. I'm going to share my screen again to share this. Yeah, and yeah, say hi to Milizim. Welcome. Welcome to the live. So I wanted to touch on 3 more things, but I think we will not spend too much time on those. One of them was coming back to the LND FUD that we saw last week. So we saw a lot of comments on social media, for example, on X or on Nostr, regarding whether there was an exploit going on for LND nodes that weren't upgraded to the latest version. We don't have a complete post-mortem yet, So we are still waiting for some official communication from the Lightning Labs team. But what we know so far is that presumably two things happened around the same time. One thing is that LND user node was compromised and some of their funds were stolen, but this has nothing to do, presumably, with LND itself. It's just that their machine was compromised and the hacker had root access to their machine. So basically, they were able to do anything they wanted on the user's machine. And so in this case, there is nothing you can really do as a Lightning implementation developer. Yeah, uh, the LND team, the last communication from LND team regarding that was that they were pretty sure that it was only due to the hack of the machine and that there was no LND specific vulnerability going on here. But around the same time, Lightning Labs published two releases, one for LND and one for Lightning Terminal. And they indicated that the releases contained important bug fixes. So there was LND v0.18.5 beta, which per the release notes fixes a critical bug related to erroneous invoice state transitions. And there was a Lightning Terminal release, which includes a critical bug fix to resolve an issue with erroneous invoice state transition. So it sounds like it's pretty much, yeah, it seems related. According to a post by Rosebeef and according to some comments made by some Lightning Labs developers, it seemed that if you're running a standalone version of LND, so you're only running LND and you're not running Lightning Terminal, you're pretty much fine, and you can update your node to the latest version if you want. It's always better to make to install updates, but it's not critical to do it as soon as possible. But if you are running Lightning Terminal, which encapsulates LND, then it is advised to make the update as soon as possible. So we don't know exactly what's going on yet, but it seems that there is some issue with um, the way Lightning Terminal handles uh, invoices. So it's for a special kind of invoices which are called AMP invoices, which is, I think, specific to LND. And the issue seems to be that it would mark so the payment can be split into multiple atomic parts. So it's a bit like multi-part payments. And the part that would reach the node would be marked as settled, and they wouldn't be cancelled even if the whole payment was cancelled, which is can be quite an issue. So you'd have a dangling HTLCs that would not be cancelled and would not really be settled as well. So it could lead, I guess, to force close. So I don't think it's actually a vulnerability, a bug where a malicious actor can really steal funds. I think it's a bit like the LDK vulnerability we saw. I think it was it was 2 weeks ago, where an attacker could do a griefing attack and force close your channels, but they can't really steal funds. But anyway, we're still waiting on some official communication from LND, and it's still advised to update your node to the latest version as soon as you can, especially if you're running Lightning Terminal. Yeah, so that's it. Feel free once again to come in the chat if you have any question, or even to come join me on stage. The last two things I wanted to cover today are option simple close and ephemeral anchors. Um, so it's new stuff that was added to the specification. As I said in the beginning, option simple close is now merged into the specification, which means that it's now really part of the specification. It also means that, so for this to, the way the Lightning specification works is that for something to be merged into the specification, it requires at least two different implementations to have implemented the new feature and to have achieved interoperability between them. In this case, I believe it's interoperability between Eclair and LND that was achieved. I think it's these implementations. And basically, it's a new protocol for mutual closing of channels. So it's when you're trying to close a Lightning channel and both peers are connected, both peers agree on closing the channel. And so you can have some kind of negotiation between the peers in order to create the closing transaction. And this new protocol is simpler. It's less prone to accidental force close due to fee disagreement. I'll come back to this in a minute. And it's taproot ready. And the key differences are that it ensures party exchange nonces that are used for signing the closing transaction when using taproot channels. So it makes sure that even if for example, if the discussion between the two nodes is interrupted during the negotiation, the first thing they will do is exchange a message that contains the required nonces for each party to craft the appropriate partial signatures in order to close the taproot channel. And another key difference with how things used to work before this new option simple close, and so how they still work pretty much in the majority of the network today. So a new big difference is that now any party can pay the mining fee, and not just the parties that opened the channel. So up until now, it was always the opening party of the channels that had to pay the fee for closing the channel, and now it can be either one of the two parties. Up. So if we take a look quickly at the pull request on GitHub, so it was a pull request by Bastien Teinturier, which is a CTO of A5, which is the team developing the Eclair implementation. And so pretty much it sums up what I explained. So the goal is to have a can't fail close protocol. So basically, it's a bit absurd to have mutual close fail, because it's a situation where both nodes are online, both nodes agree to close the channel, and so it's really weird that it can fail in some situations. And so one of the aims of this redesign of the mutual close protocol is to make sure that it always succeeds. And it's also taproot ready by ensuring that nonces are always exchanged at the beginning of the negotiation. And we can take a quick look at what changed in the specification. So as you can see, so on the left-hand side, it is the specification as it was before, and on the right-hand side, it's the specification as it is now. So, but not now, but after the merge of this modification. And so basically, it's the same at the beginning. So you exchange what is called a shutdown message, and it sees this shutdown message that will contain the nonces for taproot channels. Then you wait until all pending HTLCs are complete. And then things are a bit different. It looks more complicated in the new version, but it's only because it gives more details. Um, but basically, what happens is that uh, the two nodes will exchange two kind of message. One kind is closing complete, where basically a node says to the other node, I want to close the channel with this transaction. And if the other node agrees, so basically the other node will check that the closing transaction pays them the proper amount, that it pays fees that with no, actually I think we can disregard fees. So basically check that the transaction is uh, does in fact represent the latest state of the channel. And if it's okay, it responds with a closing sig message which contains the signature for the transaction that was specified in the closing complete message of the other peer. And vice versa, the other node can also send a closing complete message to which the node A, for example, will respond with a closing sig message. And so anytime during the negotiation, a node wishes to update their closing transaction, they will just send another closing complete message to which the other node will respond with a closing sig message. And if something happens, for example, some rare race condition, they can simply disconnect and then reconnect, and they will just re-exchange shutdown messages, so re-exchange nonces at the beginning, which makes sure that taproot channels can be closed no matter what. And so I'm just skipping to one important part, which is, I believe, yeah, the node sending closing complete, the closer pays the fees, and the side with lesser funds can opt to omit their own output. So basically, what could happen before was that you could have two nodes agree to close a channel, but then disagree on the fees to be paid in order to close the channel. And for example, the node that didn't open the channel in the first place could estimate that the fees were higher than what the nodes that opened the channel estimated before. And it could refuse to sign, for example. And if a node refuses to sign your mutual close transaction, the only way, if you don't manage to negotiate the fees, the only way to close the channel in the end is to do a forced close, which we want to avoid pretty much at all cost. And so with the fact that each side pays the fees for their own closing transaction, their own closing complete proposition, it helps mitigate this fee negotiation part. I think it's explained somewhere that the rationale behind the fact that it's basically fine to sign a transaction even if you don't agree with the fee. So yeah, here it is. The close protocol is designed to avoid any failure scenarios caused by fee disagreement, since each side offers to pay its own desired fee. If one side has less funds than the other, it may choose to omit its own output. And in this case, dust must be omitted to ensure that the resulting transaction can be broadcast. So basically, if you have less funds than the other, and even to the point that it makes no sense to add your output to the commitment transaction because it would cost more in fees to just add the output than the value of the output itself, then you can decide to omit your output from the commitment transaction. But not the other way around. Your counterparty can't omit your output. And so that's something else. I will come back to that later. Note that there is usually no reason to pay a high fee for rapid processing, since your urgent child could pay the fee on the closing transaction's behalf. So that's basically CPFP. And you can also do RBF by so if you want to update the fee, you can just, as I said earlier, just send another closing complete message, which will where you can propose another closing transaction, which, for example, pays a higher fee, and it overrides previous ones, and you can negotiate again with your peer. Yeah, and so if the closer proposes a transaction which will not relay, so for example, an output is dust, or the fee rate is that is proposed by the closer is too low, it doesn't harm the closee to sign the transaction, since after all, the worst that could happen is that it doesn't relay. Similarly, if the closer proposes a high fee, it doesn't harm the closee to sign the transaction because the closer is paying. So, of course, the best case if the fees that the closer proposes seems adequate to the other parties, then they can sign the transaction, no big deal. But even if the fee they propose seems too low, or if the sim they propose seems too high, the other party can always sign the transaction, no matter the fee, because the worst case is that it won't relay, but they can close the channel with their own closing transaction, where they pay a higher fee. Or the other case could be that the fee that the closer proposes to pay is too high, but then the other party can sign this transaction because it doesn't matter for them, because it is the closer that is paying the fee. And there is a slight game where each side would prefer the other side to pay the fee, of course, and proposes a minimal fee. So they could start the negotiation, and I don't want to pay too much, so I'm going to propose something that is, for example, below the standard relay policy. And so I'm expecting the counterparty to sign the transaction, because that's what we saw just up here. Up here. And maybe the other party will propose some higher fee rate that this time will be above the minimum fee rate for the transaction to be relayed. And it's a jackpot for me, because I managed to dodge having to pay the fees. But if both sides reason that way, then none of them is going to propose a closing transaction that pays a fee high enough for the transaction to be relayed. But the idea is that if neither side proposes a fee which will relay, the negotiation can occur again, yeah, or the final commitment transaction can be spent. So basically, it can be a forced close in the worst case scenario. And in practice, the opener of the channel has an incentive to offer a reasonable fee rate, because they are the ones that will end up paying the fees in case of a forced close. And usually the fees in a forced close are higher than the fees in a mutual close. So the channel opener is incentivized to propose at least a fee rate that will guarantee that the transaction relays. And then the parties that did not open the channel, if they are in a hurry, for example, they can propose a higher fee rate if they want. And yeah, another thing that is clarified in the specification now is on the usage of op return in mutual close transactions. Yeah, I think it's here. So yeah, as we read earlier, The closed protocol is designed to avoid any failure scenarios caused by fee disagreement, since each side offers to pay its own desired fee. And if one side has less funds than the other, it may choose to omit its own output. And in this case, dust must be omitted to ensure that the resulting transaction can be broadcast. So if you have dust in transaction, it will not be a standard transaction, and so it will not be relayed by nodes in the network. And there is a edge case. So the corner case where fees are so high that both outputs are dust is addressed in two ways: paying a low fee to avoid the problem. So basically, you pay a small fee, and maybe your transaction won't be confirmed until some time. Or the other alternative is using an op return, which by definition is never dust. And if one side chooses to use an op return output, its amount must be zero to ensure that the resulting transaction can broadcast. Yeah. And so basically, if the fees are so high that it doesn't make sense to include either output from either of the parties, then you can just close the channel with an op return output, and basically the whole balance of the channel will be just fees, but at least you're able to close the channel and yeah, get over with the channel. So yeah, basically it's a usage of the op return that isn't meant to write any kind of data, from my understanding, but it's just used to complete the channel, to close the channel, even if nobody gets funds from that. And so here, related to that, I think they tighten the rules around what can be included behind, so after the op return. So op return is only standard if followed by push opcodes, and the data script is 83 bytes or less. We are slightly stricter to only allow a single push, but there are two forms in script. One which pushes up to 75 bytes, and a longer one, op push data one, which is needed for 76 to 80 bytes. So I don't know if there is any other usage of op return other than just being able to, so I mean in Lightning channels, of course, other than being able to close the channel even if there is nothing that can be economically salvaged from this channel. Yeah, I don't know if anyone had an idea on that. Yeah. Okay, so there is some discussion here. Yeah. No, I think it's what we said. But basically, using this op return is just a way to maximize what can go into the fee. And I think it's actually, I think even Luke Dash Jr. wouldn't object to this use of op return, because at least it doesn't add bloat to the UTXO set, which would be useless. Like, for example, the alternative would be to create a Dust UTXO, which would slightly reduce the fees. But the bigger problem would be that it would create a UTXO that would be completely uneconomical. And I think it's cleaner to use a op return for this scenario. But what I don't know is why they allow, why not, if this is the only use case, if the only use case is to make a clean close for the channel, why not maybe restrict even more the number of bytes that you can push with the op return? Maybe it's just that they don't want to restrain users. And maybe there can be some additional use case for returns. So yeah, that's basically it for options simple close. Took. And the other thing I wanted to quickly cover in today's session, but once again, it's only at the draft stage in the specification right now. And it's not even completely supported by Bitcoin Core just yet. So it's really experimental stuff, let's say. So we'll not cover it too much today, I think. Is about ephemeral anchors, which is a great way to stop worrying about on-chain fees when you're doing Lightning or when you're doing any kind of multi-party protocol on top of Bitcoin. So basically, the idea is that so currently what we're doing is that we don't have this ephemeral anchor part, and when we're closing a channel, we create a transaction that spends funds to so one output for Alice and one output for Bob. So here, for example, it's the as viewed from the point of view of Alice, and you have to pay some fees. So here it's a commitment transaction for Alice, for example, and you have to pay fees, but you don't know when the commitment transaction will be published in the future, and you don't know what the on-chain fees will be at that point. So you need to estimate the fee. Usually what you do is you take the current fee and you multiply it by some factor like 2, 3, or 4, and you say, I hope that it will be enough in the future. I think it was a year ago, maybe a bit more, an improvement was made to that system where you can have anchor outputs, which are basically dust outputs. So outputs which value is 330 satoshis. And the only goal, the only purpose of these outputs were to be spent in order to CPFP the transaction. So CPFP is when you have two transactions and that are sequentially linked together. So you have what we call a child transaction that spends an output from the parent transaction, which means that if a miner wants to include the child transaction into their block, they need to first include the parent transaction. And that's a way to bump the fees of a transaction by spending one of the output of the transaction in a child transaction that pays a higher fee, and a fee so high that it is enough to cover for the cost of both transactions. So that's why it's called child pays for parent, because basically the child transaction will pay the fees for both itself and the parent transaction. And so if you want to bump the parent transaction by a lot, you just create a child transaction that pays a lot of fees. And there are some rules around what is allowed and what is considered standard for child transactions in order to avoid some kind of pinning attacks and some kind of DOS. But basically, that's what we have now currently. That's the best way to deal with fee rate uncertainty, is to use anchor outputs. The only issue we have right now is that the way mempools work currently in Bitcoin Core, when a miner considers transactions for inclusion in a block, they don't really take both transactions as a package. And so it it's kind of working, but it's not completely working just yet. And we have new rules, new mempool rules that are coming to Bitcoin Core gradually, which help ensure that when a miner is considering which transaction to include in their block, they will, if they see one transaction and then a child transaction that spends from this transaction, they will immediately see that the whole package is paying a certain fee, and that the fee of the whole package is enough to justify to put the both transactions into the block. And once we have that, we can even go a step further, and instead of using anchor outputs that are dust, we can use what we call ephemeral anchors, which are basically outputs that can have zero Satoshi value. So they can be output for 0 Bitcoin at all. So it's something that shouldn't be allowed because it would clearly be dust, but it's allowed if and only if it is immediately spent. So if this output is immediately spent by a child transaction that pays the fees for both transactions. So basically, it's a way to do a CPFP, but with a zero value anchor output. And this, in order to ensure that these anchor outputs are spent, you can also design them so that they can be spent by anyone. So basically, anyone, including the miner, can spend the anchor output. And so, yeah, that's basically the idea behind anchor outputs and ephemeral anchors. And if I share again my browser, so I think it's here. Yeah, so here there is a draft, once again by Bastien Teinturier, on using zero-fee commitments, using V3 transactions. So basically being able to publish commitment transactions that don't pay any fee. So it would be a new channel type that leverages V3 transactions. So basically that's the idea that you can cluster transactions together when they are linked together and see that and see them as a package. Pay to anchor outputs, so that's the and ephemeral dust. So that's what I just said. It's basically being able to have outputs that can be spent by anyone, and being able to have zero value outputs or some value outputs on the condition that they are spent immediately. With this change, commitment transactions don't pay any mining fee, which get rid of update fee and all of the related channel reserve issues. So right now, what you're doing is that, so right now, right now with having to pay fees in commitment transactions and having to guess what the fees are, what we do is that anytime there is a fee spike, for example, of some fluctuation in the fees, two Lightning nodes that share a channel will exchange update fee messages in order to update the last commitment transaction in order to account for the new fee environment. And they will also need to keep the corresponding reserve, which means that, for example, if the current on-chain fees means that you've agreed with your channel partner to sign a commitment transaction that spend 10,000 sats in fees, you will need to keep a fee reserve of 10,000 sats on your channel, which means that these 10,000 sats are on your side of the channel, but you cannot spend them because you are keeping them in reserve in order to have them at hand if you need to pay the fees for the closing transaction. It also gets rid of, yeah, it's what's written here. It also gets rid of the undesired channel force clauses that happen when the mempool fee rate spikes and channel participants disagree on what fee rate to use, which has been a major source of wasted on-chain space. So basically, this would happen when nodes would see some fee rate spike in the mempool, and they will send an update fee message to their partner saying, oh my God, the fee rate now is 50 sats per VByte. We need to update our latest commitment transaction in order to be sure that we can publish it later. And if the channel partner didn't have the same vision of what the fees were, they could refuse to sign the new commitment transaction because it would seem like some kind of griefing attack, for example. But in any way, it would seem nonsensical to them because it would ask them to sign for the payment of a fee that is too high compared to what they are under the impression that the current fee is. And so it would lead to the node that asked for a fee update to force close the channel now in order to be sure, in order to avoid the case that would arise if they didn't now and they couldn't close the channel later because the fee had skyrocketed. So they see that there is a fee spike, a spike in the fee rate. They asked their channel partner to update the latest commitment transaction. The channel partner doesn't see the same thing, and so they refuse to update the fee in the commitment transaction. And now the party that asked to update the fee has two choices: either to say, okay, let's not update the fee, or to force close the channel right now, because they prefer to be sure to be able to force close now rather than being stuck later with a channel that can't be closed because the fees are too high. So that was basically what drove a lot of accidental channel force closes in the past, which was, as Bastien Couturier says, a major source of wasted on-chain space, and yeah, a major. It was also just a loss of time for node operators and all that. And now with the fact that we don't have that the commitment transaction don't even have to pay fees at all. We don't have to try to guess the fee, and we don't have to update the fee when the fee rate evolves in the mempool. So it completely removes all these problems. It also offers better protection against spinning attacks thanks to package relay, and reduces the on-chain footprint compared to anchor output channels. So pinning attacks are attacks where, for example, you could, it's what I mentioned a bit earlier, but you could, for example, so your counterparty could publish a transaction that would spend some output of the commitment transaction, but with a very low fee, and in a way that would require you to pay a very big fee in order to be able to bump the fees of the closing transaction. And in order to mitigate this kind of pinning attacks, there are all kinds of requirements, for example, today on Anchor outputs. And actually, Anchor outputs were designed in order to mitigate pinning attacks. But these ephemeral anchors are even better than anchor outputs because they have a smaller on-chain footprint. Because in order to avoid pinning attacks in anchor output channels, you need to have two anchor outputs, one per channel participant. Whereas here you can have only one ephemeral anchor which can be spent by anyone. And we use a single anchor output whose amount is the sum of all trimmed outputs and thus maybe zero sat. So trimmed outputs are when you have HTLCs or other outputs actually in the channel that are too small and don't make sense to add to the channel. Then you can. So currently, what we do is we add them to the mining fees, but now in this construct, we can add them to the anchor output, and we remove the one block relative delay used by anchor output channels. This allows using our channel outputs, main balance or pending HTLCs to CPFP, a remote commitment transaction. No need to add external outputs. So this one is quite important for mobile wallets. Once again, in order to mitigate some pinning attacks, when using anchor outputs, there is a rule that you have to wait one block before you can spend the anchor output. So it makes sense because it is in order to prevent some kind of pinning attacks. But the issue with that is it means that you need to use other funds than the funds contained in the closing transaction in order to CPFP. So to use child pay for parent in the transaction. You need to have some other UTXOs laying around that you can use in order to fee bump the closing transaction. Now with ephemeral outputs, you can use the outputs that are inside the closing transaction you're trying to fee bump in order to fee bump the transaction, because you can spend from directly inside the same block. So you can have let's go back to my schematics. It will be easier to explain. You can be in this situation where you publish a transaction, and let's say we are Bob. We can actually use some funds from our own output in order to fee bump, to spend from the transaction, from the ephemeral anchor in order to fee bump the transaction. And this is possible because we don't have to wait one block before spending the anchor. And so this is great for mobile wallets because one of the big issues with anchor outputs in mobile wallets is that usually mobile wallets, for example like Phoenix, don't have UTXOs laying around that can be used to spend the anchor. And this is especially a problem in one specific case, which is when the mobile wallet is receiving HTLC. In this case, the other node, so for example, in the case of Phoenix, it would be the node from A5, could try to steal the money that is contained in the HTLC by fulfilling the HTLC. So they receive the preimage from the Phoenix wallet. They pass the preimage back to backwards into the route. So this way they can claim the money that is in the HTLC, but they just don't update their commitment transaction. They don't revoke the previous commitment transaction to reflect this new state of the channel between them and the Phoenix user. And then they wait for the HTLC in this channel between them and the Phoenix user to time out, and they try to claim it on-chain. And then, in this case, in this situation, the Phoenix user needs to act quickly in order to broadcast the commitment transaction, broadcast then the HTLC success transaction after the commitment transaction. And they must do so quickly because they must have both transactions confirmed before the HTLC timeouts. And so it comes handy here to be able to fee bump the transaction. And it's even more, but the problem is that with the current design, you can only fee bump a transaction if you have additional UTXOs laying around. And in this specific situation, you don't necessarily have time to go to an external on-chain wallet in order to grab a UTXO that you can use to fee bump the transaction. You need to act quickly, which means basically we need to have something that can be executed automatically by the wallet. And having ephemeral anchors helps doing that because you can spend directly from using the same outputs that are in the closing transaction, in the commitment transaction that is published. And so it removes this potential vulnerability for mobile wallet users. So yeah, that's basically it for today. I hope it was clear enough. I hope it was interesting. Feel free to tell me if you have any question, any feedback. I will bring back on screen the Telegram group. If you want to join us on the Telegram community, please do so. We are now 12 members. So the goal is to have everybody gather in this Telegram group where we can discuss between sessions. Everybody is encouraged to share links in this Telegram group. So basically, when you see news, new developments, and you think it would be interesting to discuss about this stuff during the live sessions, you can come to the Telegram group and share your links there. So of course we have some moderation policies around links. So I have to manually whitelist domain names. But so far I've whitelisted a few of the usual domain names. For example, x.com is whitelisted. njump.me for Noster links is whitelisted. Delvingbitcoin.org is whitelisted. Actually, I can get the list, I think. Yeah, I whitelisted Lightning Engineering, which is a Lightning Labs blog. So yeah, there are already a few domains names that are whitelisted. Yeah, stacker.news, github.com, delvingbitcoin.org, mempool.space, planb.network, wikipedia.org, x.com, and njump.me are whitelisted. But if you have a link that is not in the whitelist, you can just send me a message. Of course, I'll review what you're trying to post, and if it's okay, I whitelist the domain so that you can post the link. But yeah, the idea is that we can have a collaborative news feed this way, and we can discuss what would be interesting for everyone to discuss in the next live session. So yeah, that's it. Thanks a lot for tuning in. I hope it was interesting, and see you guys in the next session. Bye bye.